All right, so now we're going to evaluate. First, it says find f of 2. So raise your hand if you can tell me what we do with this piece. How do we evaluate f of 2? How do we evaluate f of 2?
Substitute x with 2.
Yes, well said. Substitute x with 2. So let's go. Here we go. Well, which one has a 2 in it? Which piece? Does the first piece have a positive 2 in it? No, because it said the first piece, all the x's have to be less than negative 2. How about the second piece? Does the second piece have 2 in it for x? Yeah, because it's in between, as you can see, negative 2 and so x of 2 is right there. So you're going to pick what piece? Second piece, okay? So I'm going to go and pick the pink one. So pick the second piece because remember, you have to find where 2 is for x and then pick that piece. So we're going to go find f of 2 by picking the second piece. I'm going to write second piece in it. Every piece is going to have or allow a different x value. So we're going to plug in negative 1/2 times 2 plus 6. Okay? So negative half times 2 is what? Negative 1. Negative 1 plus 6 is what? 5. So f of 2 class comes out to be what? 5. We're going to box that up. I'm going to hold tight. Any questions so far? Then let's do a couple more just to get the hang of it. Find f of 8. I want you to look at all the pieces, and then I'm going to call on you if you need to talk to your team. Out of those 3 pieces, find f of 8. Which one of the pieces contains an 8 in its x location? So think about it. Can you, when you have an idea or an answer, can you please consult with your team? Share your idea with the team. So Haley, did you decide on which piece contains an 8 for x? The third piece is right. Good job. Okay, third piece. So I'm going to use the third piece to plug in. But class, what happened to the third piece? What is the y value? What is the output? Always when x is greater than 6. It's always what? 3. So it doesn't matter if I go to 8. I go to 8, the output is just still 3. So guess what? I just write 3. I don't even have to evaluate anything. I just need to know what the output is when x is 8. What's f of 7? Also 3. Why? Because anything greater than 6, y is always 3. What is f of 100? Also 3. You're right. Okay. So now let's go do this one. Last piece in here, it says find x. Find x when what? F of x equals how? Negative 9. Give me another variable that I can substitute for f of x. Someone said it. Y. You're right. Okay. Guys, f of x is the same thing as y. Okay. So I can see it like that as well. So f of x equals negative 9 or y equals negative 9. Now let's look at the pieces. Out of those 3 pieces, which one contains a y value of 9? First piece, second piece, or third piece? Which one has a y value of negative 9? First piece, yeah. Look, the 2 pieces above would never hit negative 9 for y. So when I'm looking for x, I have to use first and only first piece, okay? So that's what I'm going to go back and plug in. What am I going to plug in? What am I going to plug in? Negative 9 for? Y. All right, let's do it. Negative 9 equals 2x plus 1. How do you solve for x here? Because it says find x. Minus 1 from both sides. That gives me what? Negative 10 is right. Okay, so I'm out of space, so it's going to go right here. Negative 10 equals 2x. What's next? Divide both sides by 2. It says find x. What's your x? Negative 5. Box that up. Okay. I'm going to pinch it in so you can have the whole visual right there. Okay. And hold on tight before I go any further. All right. Now, this one says graphing piecewise functions. Okay, I'm going to ask you to help me read it really quickly. So, Joe, can you help me read number 1, please?
Determine how many pieces there are based on the number of equations.
Perfect. Okay, so determine how many pieces. Okay. Can you please help me read number 2? Nickel L? Read number 2.
Determine what shape each piece is a segment or array going in which direction.
Thank you. So tell me if it's a segment. I mean, it starts and it ends. Or tell me if it's an array. Okay. And then number 3, can you please help me read number 3, Bouquet?
Determine the x values of the endpoints of each based on the domain.
Perfect. Okay. Ben E, can you help me read number 4, please?
Graph each equation or its domain.
Oh, sorry. Number 3, we forgot. And whether they are exclusive or inclusive. Which, by the way, exclusive means are they there? No. That means what kind of circle? Open. Okay. Inclusive means it does exist. That means you want to be a closed circle. Okay. Thanks, Ben. 5, can you help me read number 5, please? Let's see. Ariana?
Double check that what you have graphed is a function vertically like.
Yeah. So double check if it's a function. To check it, we use a vertical line test. And number 6, can you please help me? Aaron R, help me read number 6.
Find all the information asked for about the function.
Right, just like what we just did. Okay, find f of 2, f of 8, find x when y is -9. Let's try this one. We're going to start graphing. Here we go. Jennifer, can you tell how many function in example 2 are we trying to graph? How many function? Not how many pieces, how many function? One function, because how many f of x do you see? One. Okay. Now, how many pieces, Shelby? 2. You're right. Okay. That means I only need to make 2 t-charts. By the way, are you mandated to make t-charts or t-tables? No, you graph however you want to graph, but I'm lecturing, so I'm going to graph it where I think most students will understand. I'm going to graph the first piece here. First piece. I'm always going to do in pieces, okay? What is a good starting x value for our first piece? We're gonna, -7's a good one, but that's not going to be my first piece. First input. I would start with my negative what? 6. And what kind of circle would I have? Open. You're right. Okay. You want to start there. Even I know it doesn't equal, it has to be less, but I can have an open circle. All right, here we go. 2 times -6 plus 7. Griffin, what's the output for this one? -5. Do you guys agree, Griffin? And this is going to be what kind of circle? Open circle. Very good. Okay. Then I'm gonna get. I normally use 3 just so that I can have a nice straight line. Okay. So, Ashley, give me your next input. Of course, -7 sounds great. Okay. So let's plug it in. 2 times -7 plus 7 equals 2 times -7 is what? -14 plus 7? -7, okay. The third one is optional. The reason I always do the third one is because I want to have a straight line, or if I messed up, then this will help me verify it, okay. Gabriella, can you help me to get the output for this one? -9, do you guys agree? All right, let's plot the dot. -6, go down 5, -2, 4, 6, 2, 4, 5. Open circle, it says right there. -7, go down -7. Okay. And then -8, I need to go all the way down to -9. Okay, looks like my dots are all in straight line. That means I did my basic math correctly. Use a straight edge, please. I have to go find a ruler very quickly. Use a straight edge, connect the dots. Where are my rulers? Oh, here it is. If you don't have an ID, then go grab a ruler from the back. Okay, there you go. Then we are going to use a second piece. So second piece. Okay. Second piece, here we go. Let's start with the first input. What do you guys want the first input to be? Also what? Also -6. By the way, what kind of circle is that first piece going to be? Closed, because it's equal to then. Okay. Then I'm going to pick, can I pick -5 and 0? I like 0. Why? Why do we like 0 so much? It's easy to use. Okay. Do I have to pick -5? Can I pick -4? Okay. If you want to, you can pick -4. Is that still okay? Yeah, you can pick any 3 values you want. But let's plug in -6. So it's going to be -1/2 class times -6 minus 4. What is the output for this one? -1/2 times a -6 is now a positive what? 3 minus 4. -1. Okay. Let's do the second one. -1/2 times -4 minus 4 again. So this is -1/2 times -4 is now what? -2 or +2? Positive 2 minus 4 is -2. And then 0, I love 0. 0 times -1/2 is 0 minus 4? -4. Okay. So let's plot those dots. -6 is now -1. And we said it's going to be what kind of circle? Close. Okay, close. -4 is going to be just -2. And then we have 0, go down 4, 2, 4. Now, if you think you got some dot that's not on the line, go back and verify your basic math. Okay, these are beautiful. Go ahead and draft that out on your notes. Use a straight edge, please. No waving lines. These are straight lines. Okay. Allie W, is this a function, dear? Is this a function? How do we determine whether your piecewise is a function or not? What kind of test? Consult your team. You don't ever have to be alone. Yes, you have to use a vertical line test. So Allie, if I were to draw a vertical line test anywhere, will you ever, or will that line ever intersect more than once? No. So is this a function, dear? Yes. Okay, it's a function. Very good. Oops, you just said yes. Is this a 1-to-1? Joe, is this a 1-to-1?
I don't know.
Consult your team. Come back to me. How do you determine whether a piecewise or any function really is a 1-to-1? What kind of test? What kind of test?
That's going on.
So Joe, what kind of test would you have to do to pass? This would be a 1-to-1 function.
Oh, horizontal.
Horizontal line test. Okay, let's draw. Whoa. How many times did I cross over when I draw that horizontal line test? Twice. So did it pass or fail? Fail. So is this a 1-to-1 function? No. No, not at all. All right. Is this continuous? No. How do you know it's no?
Because you have to lift your pencil.
You're right. It's not continuous. Okay. Now let's check out the domain really quickly. Think about this. I want you to think really long and hard. Kimmy, what's the domain? All real numbers. You guys agree with Kimmy? Okay, would you have some negative x over here at some point? Yes or no? Yeah, because the arrow. And they'll keep on going on the x-axis. Well, there's a hole. I thought there's a hole doesn't exist. But what? It's filled in with that hole. So this x right here, do you have an x value right here at -6? Yes or no? Yes. Keep on going. So Kimmy's right. This is what? All reals. Okay. Heidi and team, think about the range. What's your range? Remember, range is explaining what value, x or y. Is it all real numbers? Is the range all reals? Think about where it starts when you have a negative y value. So, think about where. Class, will negative y value exist? Yeah? Would you have negative infinity for y value?
Yes.
Yes, okay. Do you have a 0 for y value? No. How high does it go up to?
-1.
-1. Inclusive or non-inclusive at -1? Inclusive, because there's a closed circle. Okay? So guys, look at the bottom. The arrows means what? You're going to have a negative infinity. I'm going to keep going up, going up. And the y value stop where? At -1. And that's inclusive. What kind of symbol do we use for inclusive? Bracket. So it starts at negative infinity, go up to -1, bracket. Can I use bracket for infinity ever? No, because infinity cannot be inclusive. We don't know what infinity is right now to be inclusive. Okay, let's evaluate. Find f of -8. You have to determine which piece contains -8 for x. Which piece? First or second? First. Okay, then we're going to go to first and plug in 8 for x. My first piece, I was using blue, so I'll keep it consistent with blue. So first piece was 2 times -8 plus 7. So let's plug it in. Nicole F., can you tell me what that is, please? 0. Well, -2 times -8 is -16. Okay, -16 plus 7 would be -9. Much, much better. There you go, box that up. Okay. Let's evaluate f of 5. First piece or second piece, honestly? Team, work it out if you... Second piece, you guys agree? Okay. F of 5 is the second one, so let's plug it in. -1/2 times 5 minus 4. -1/2 times 5 is positive or negative? Negative what? 5 over 2. Okay, 5 over 2 minus 4. By the way, -5 over 2 is the same thing as -2.5. Yes or no? Yeah, both are the same. So what's -2.5 minus 4? -6.5. Leave it as -6.5 or pick in mixed fractions or improper as long as it's the simplest form. All right, find x when y is? -4. All right. Well, which piece?
Second.
Ah, yeah, the second one has a -4 for y. You're right. So I will use the second one to find x. That means 4 equals, -4 equals -1/2 x minus 4. Okay, so tell me where to go. Sophia, what's the first step in solving for x here? You're right, add 4 to both sides. Oh, I like this one. That means, what's on the left side?
0.
Oh, I love zeros. Okay, so now I have -1/2 x equals 0. How would you get rid of that -1/2? Divide both sides by -1/2 or multiply both sides by -2 over 1. They're both the same, okay? So if that's the case, what's x? I love 0. X is 0, okay, when y is -4. And I thought we do a table like that already? Can you guys see up here? That's your match. So, and by the way, you don't have to write all that basic stuff out if you're already new, okay? All right, check for you. You guys get to it. Let me see if I can pinch it in to make sure all of it is showing, because not all of us have printed notes. I hand out homework for tonight. Did everybody get one? I want to make sure all the teams got How many functions? 1. How many pieces? 3. Right. 1 function, 3 pieces. What's going on with the middle piece? That is so funky. What's the middle piece say? Y is what? Y is at? The middle piece? Y is at where? When and yeah. How do you have that line? Is that even a line? It's just a what?
Point.
It's just a point, not even a vertical line, not a horizontal line. It's just a point. There's only one x. If x is 0, when y is -3, just a point. Once you have the first piece graph, can you compare it with your team? Because the first piece is wrong, and the second piece is and the whole function is wrong. So compare one piece at a time. And make a chart if you can't see what values you're using. So you first you need to pick inputs. So what's your start? First piece. I can have a 0, but that's later, so it's very small, it's extra. Y is 2x plus 5 if x is -3 times the 0. So you want to put this piece as your first input. Then you're going to pick 0, because that's the last piece. So this is first and last. And what is another one you can pick in the middle just to verify your value? Yep. Now at -3, what is your one? I think when x is -3. Right? This is equal sign. Now at closed circle,
The -0, 5, I don't know.
you're right. So I'll plug it into the first piece. Well, you have to pick at least 2 points. I usually pick 3 so that way I have a nice straight line. So -3 is the next one. It's the first one. What's your next input for that first piece? No, you can't pick 5 because remember, x is only limited from where to where. 0. Yeah. So your first piece is perfect. You can pick the last piece, which is what? Right. I pick another one in the middle. You're right. Also, why not just be ignorant? And that's what because you want to have a starting point. Don't raise that one. You don't have to work out. Just I know you want 0.
That's a point. I don't know.
No, you don't have to.
Which one are you talking about?
Yeah, so there's only one x.
Oh, there's one point. There's no line.
So you still go.
It's just that there's equal 0, -0,
Now this would you have an arrow at all? Would you have a razor? Right, so starting point and you can't. So and
Oh, wait, that one? I went.
Okay, so I'm just going to look for 3 inputs on the first piece. Okay, so if you need to, please consult with your team. Aline, can you give me your 3 inputs? What's your starting input for first piece? -1 is correct, but I wouldn't pick as my first input. What would be a good first input for most of us? Jennifer?
-3.
Yeah, what's the last input, the third input?
0.
0. You're right. It's a segment. You want to know when it starts and when it ends, okay? Because it's not a line. It's not an array. And then in the middle is when you have a choice. In the middle, can you pick -2 or -1? Yeah, that's really up to you. Okay. Some of you pick -2. I saw some of you pick -1. It's really up to you. When you pick -3, -3 times 2 is -6. -6 plus 5, what's that first output? -1. Okay. When you pick 0, 0 times 2 is 0 plus 5 is 5. Okay. This is your first piece. Then -1. When you pick -1, 2 times -1 is -2 plus 5. What's that output right there for those of you who pick -1? 3. Okay, so let's plot that. -3, -1. Class, is this open or closed circle at -3? Close or open? Close, because it's an equal right there. And then -1 go to +3, right there, and 0 go up to 5. Okay, open open circle or closed circle at 0? Open. Okay, so that's kind of where that is. Any question on that first segment? Pretty sure you get that first segment correctly. It starts and it ends. Good. Okay. That's your first segment. There's a starting closed circle and it ends at an open circle. Second piece. What kind of second piece is that? Is it a segment, array, or just a point? A point. When x is 0, y just simply at -3. You go and plot your point. That's it. Yes, it can be part of a function. A function does not need a segment or array or a line. It can just be a bunch of dots, as we know. Third piece. What is your starting point for the third piece? 0. Open circle or close? Open. So 0. 0 times -5, 0. And I'm going to write open circle. So that in my mind, I'm not going to forget. I can pick, what else? Can I pick -4? Can I pick -5 for the third piece? No. What has to go which way? All right. Give me 2 more inputs. What's your next input? 1. Sounds like a great one. And then 2. All right. Let's. 1 times -5 is -5. 2 times -5 is now? Perfect. Let's put those in. Open circle. It said so. 1 is now -5, which is down here. 2, 4, 5. 2 is -10. Is it a segment, array, or just a dot? What is it? Array. Okay. It goes forever one way. Okay. I'm going to hold on tight right there. Is this a function? Does it pass the vertical line test? Yes. Okay. It's a function. Now, is it a one-to-one function? No. This is really the problem right here, right? This one right here that doesn't pass, and then this dot. If I make a horizontal line test, can you see that it crosses twice right there? So it's not a one-to-one function. Okay. Is it continuous? No. By the way, can it be continuous? Sure, at times. What is the domain of this function? Let's start with the negative side. Remember, I always start with the negative side. Does it have negative x over here somewhere? Yes or no? Be mindful. Do we have an arrow? Let's go to the left. No, I don't have any negative infinity. But where do we start? At -3. Inclusive or not inclusive? Inclusive, because it's a closed dot. So parentheses or bracket? Bracket, -3. All right. Let's keep on going. So start at -3. Do you have a -2? Yes or no? -1? Do you have a 0 for x? No. Well, isn't that right there? Yeah. Do we have a 1, 2, 3, 4, 5, 6? Infinity? Yeah. How do I know I would have an infinity on x? The arrow. So from -3 all the way to what, y'all? Positive infinity. Let's start with the range. Well, how do we always start? Top or bottom? Bottom. Do I have a negative infinity? Yes. Do I have a -100? Yes. Do I have a -10? Yes. Do I have a 0? Yeah, I do. Even though this is an open circle, isn't there something right here? How high up can I go? How high up is that? Inclusive or non-inclusive at 5? Non, because what kind of circle? It's an open circle. So it starts at, remind me one more time, it starts at where? Negative infinity all the way to 5. Both parentheses, both brackets? Both parentheses, okay? All right, find f of 0. This one should be an easy one. What's f of 0? Negative 3, because it says it's just a point, okay? F of negative 5. Oh, do we have it? No. It doesn't exist. NA, y'all. It doesn't exist. There's no x at negative 5 on your domain ever. Find x when y is negative 10. Which piece are we going to use? First, second, or third? Third. All right. So negative 10 equals negative 5x. Okay, tell me what x is. 2. Didn't we find that already right here? Yes, x is 2. Okay. And that is done for today. Just a reminder, did we all grab a homework? Can you write homework number 5? Perfect.